Welcome to my channel, and I am discussing today about database management system. So it is basically an add-on course I have started, and the gate question and answers I shall discuss with you. And it is an initiative from SRM Institute of Science and Technology, Kattankulattur. I am Dr. Manoj Kumar Rana, and I am a research assistant professor from the Department of Computing Technologies. First, I want to present the syllabus of the GATE for the subject DBMS, and these are the small topics which is part of the whole DBMS subject. I have divided them into five uh, parts, which are some basic parts, which are some advanced parts, but all are in the syllabus of GATE for this subject. Now, the first one is the database concepts, which is the basic one. The student has to have the knowledge of the basic things like attributes, tuples, schemas, keys, the entity relationship model or ER model, and SQL is the second part. Our student has to know the structured query language, the queries, the complexities, and third one is relational model, how relational algebra and tuple calculus will be discussed. Then the integrity constant or normal forms from first normal form to fifth normal form, including Boyce code normal form BCNF, are discussed. All the questions of gate, transactions and the concurrency control at the end. So in this course, it is an add-on course. In this course, we shall discuss the things in a very easy manner, and the gate questions, mainly the previous uh, 15 to 20 years gate questions, I shall discuss, and the tricks that I shall tell you about it. And whenever you will practice these things through these video lectures, it will be highly beneficial for you for the upcoming gate exams. I can believe, because the GATE exam, the question and answer will never be repeated, but the tricks and the things that the basic understanding, if you have, you can crack the GATE exams very easily. Crack means here qualification only, but if you do better, your rank will be better, obviously. So, so I'm going to the first topic, that is database concept, attributes, topics, keys, and entity relationship model. I'm going to discuss all the questions one by one for this topic. So I'm going to the first question. It came in GATE 2008. You see the diagram first. In this diagram, there are three entities, N, P, and N, and two relations. One is R1, another one is R2, where the entity N is completely associated with R1, and entity N is completely associated with R2. The attributes are shown. For example, for entity N, the attributes are M1, M2, M3. The primary key is labeled by underline for all. And the question is the minimum number of tables needed to represent M and P R1 R2 is, the options are 2, 3, 4, and 5. Now the thing is, uh, we know that number of table is created when two entities are associated with one relation. For example, M and P are related with the relation named R1. So in this case, how many tables are possible, that we have to think first. But the thing is, in the question, the cardinality of the relations with the entities are not given. But one important thing is given that they have told that the minimum number of tables. Now that is the key concept or the key idea that we have to think about. Minimum number of tables are possible when the cardinality is 1 to 1, 1 to n, or n to 1. That is 1 to 1 relationship, 1 to many, and many to many 1 relationship respectively. If we assume many to many, that is ms to n, then obviously the table will be, there will be three tables. For example, if n R1 and P, if we consider only this part, the number of tables will be 3 if it is in a many to many relationship. But if it is the other cardinality, then only two tables are there. Similarly here, in case of P, N and R2, if we consider the minimum number of tables, that cardinality obviously be either 1 is to 1 or 1 is to m or m is to 1. So the solution I have written in this format, that I have told the same thing here, that we know for m is to n cardinality number of tables is 3. That is the maximum one. So in this case, if we assume the cardinality less, obviously the number of tables should be 2. Now, if we go to the picture again, the number of tables for this relations is 2. For one table for n, one table for p. Okay. Obviously, the primary key will be shared between the tables. Similarly here, and another thing is the table number which is associated with P will be common for both, that is N, P and N. But the table will be for one for N, one for P and one for N. So the total number of table will be 3 only. Okay. Now people may have the question in their mind that what is this double diamond, double lined diamond and double line here. So here I have given an explanation. So here the relationship R1 is strong and R2 is weak. Okay. So entity N has total participation to R1 while P has partial participation, but it does not affect the number of tables. Example, M is a professor, P is a department. So they both are dependent with each other. And suppose the department IT is the key. Ultimately, there will be the two tables for M and P when the cardinality is 1 is to N. One student cannot belong to multiple departments. Okay. Similarly, P is the owner entity of N with the relationship of weak entity R2. Okay. But it does not affect the number of tables, and so ultimate answer will be number of tables will be 3. So option B is correct here. Okay. Now we go to question number 2. So it is a question of in 2018, and the question, you have to read the question first very carefully in GATE. Okay. In an entity relationship ER model, suppose R is a many to one relationship from entity set E1 to entity set E2. Assume that E1 and E2 participate totally in R and that the cardinality of E1 is greater than the cardinality of E2. Which one of the following is true about R? Now the question says that it is a many to one relationship. Where which is many? E1 to entity E2. Okay. So, and also says another thing, that E1 and E2 participate totally in R. Okay, and that the cardinality of E1 is greater than the cardinality of E2. Which one of the following is true about R? Now the options are like this. Every entity in E1 is associated with exactly one entity in E2. Okay. Some entity in E1 is associated with more than one entity in E2. So all the options here are basically try to get the answer from you whether you understand the cardinality good or not. Okay. So 1 is to 1, 1 is to n, m is to 1, m is to n. If you understand, then it will be easy to understand, give the answer. Now the answer is like that. Since it is a many to one relationship, we may assume E1 as student, suppose, and E2 as department, R as belong to relation. Okay. Both entities have total participation, as department and student both cannot exist without the existence of another. Now, first I consider C. C is written as every entity in E2 is associated with exactly one entity in E1. So, it is incorrect because one student cannot belong to many departments according to our example. Similarly, if we say D, every entity in E2 is associated with at most one entity in E1. Okay, so it is a one-to-one relationship because every entity will be at mapped to one and only one entity in E2. So it is a one-to-one relationship. Now B, some entity in E1 is associated with more than one entity in E2. Okay, so some, that means many, more than one, that is also many. So it is basically a many to many or MS to one relationship, and it is also incorrect according to the question. Fourth, option A is here it is said as every entity in E1 is associated with exactly one entity in E2. Okay, it is true. Because in database cardinality language, every entity in E1 is associated with exactly one entity in E2 means M is to 1, that's many to one relationship. That is actually given in the question. So this option is correct. Okay. Now we can go to the next question. Question number 3, as per my slide, and it came in 2008 gate. If you see question number 1, the same diagram is drawn here, and we can say that it is a conjugate question. That means the question number 1 is given in 2008. We go to question number 1. The 2008 question. Now in question number 3, this question is following that question. Okay. But the question and the options are different. So which of the following is a correct attribute set for one of the tables for the correct answer to the above question? Okay. So which one of the following is a correct attribute set for one of the tables for the correct answer to the above question? Now the options are given. From question number 1 solution, we see that there are three tables possible. One is for A, one is for P, one is for N. And the table for N has a pair of attributes with table of P. Similarly, table of P has a share of attributes with table of N. Hence, the, at, the attributes which are will be in the table will never be a mixture of attributes of the table for entity M, for entity P, and for entity N. So in option A, the entities, so the attributes M1, M2, M3, and P1, and maybe I have given the solution here in the slide. So in the table, there are three tables as a whole with attributes M and P. M has total participation on R1. With attribute of P, P has partial participation on R1, and P is a strong entity come owner of N. And with attributes P of P and N, because N is a weak entity, and it has to keep the primary key of its owner P. So option B and C are incorrect as they involve all the entities. Okay. Option B is M1 P1 N1 N2, C M1 P1 N1. These are incorrect because it involves all the attributes of all the entities. It should not be correct. Similarly, option D may be correct if and only if there is an M is to N relationship, because option D is saying M1 the primary key of M entity and P1 primary key of P1 P entity. Okay, so it is only correct if the relation R1 has a separate table, and when a relation has a separate table, the cardinality must be M is to N. But as I have told, question number 1 and question number 3 uh, are conjugated, and hence the relation cannot be M is to N, and this option is also false. So the remaining option is option A, which is correct because it contains all the attributes of M and the primary key of P1 as a foreign key in the table. Option A is correct. Now question number 4. It came in GATE 2005. It's an old question, and the question is interesting. Let E1 and E2 be two entities in ER diagram with simple single valued attributes, that is they are in one in it. R1 and R2 are two relationships between E1 and E2 where R1 is one to many and R2 is many to many relationship. R1 and R2 do not have any attributes of their own. What is the minimum number of tables required to represent this situation in the relationship model? Okay, so options are 2, 3, 4, 5. Okay, let me see the answer. So basically, the question is saying like this diagram, if you see entity E1 and entity E2, there are two relationships in between them. One is R1, one is R2. The cardinality 1 to M for R1, cardinality M is to 1 for R2. Now, the solution I can explain like this. Since E1, R1, E2 is M1 is to M cardinality, two tables will be there. Is a need of two tables, one for E1 having pk attributes of E2 and another for E2 having all the of its own attributes. Okay. But another relation R2 exists with image to n relationship cardinality, and so three table is must. So one table for E1 uh, having pk attributes of E2, one is for E2 having pk primary key attribute of E1, and another for R2 having primary key attributes of only primary key attributes of E1 and E2. So three tables for this. Now, ultimately, for E1, there will be only one table, although I have told here two times, but that is only one table after consolidating. For E2 also, one table. Okay. For R1, there is no table, and for R2, there is one table. So ultimately, there are three tables, and so option B is correct here. So thank you for watching. The remaining parts I shall discuss in the next video.